Okay. Assalamualaikum warahmatullahi wabarakatuh. So today we are going to continue 4.2 extremum problem. Okay, we have three outcomes. Okay, the first one we discussed last week, find the stationary points. So today we will discuss for identify minimum and maximum points by using the first and second derivative test. Okay, and solve optimization problems. Okay. Okay, identify minimum and maximum points. Okay, extremum point of y, function y, can be found by steps below. Okay, the first step is you differentiate. Okay, you differentiate the equation, equation y. So we get y prime or dy dx or f prime x. Okay, then next you equate dy dx or y prime is equals to 0. So we get the value of c. Right. So value of c, that is x lah. Okay. X is equals to c. So x equals to c we call as stationary value. Right. So biasanya 1 ataupun 2 lah. Okay. Then from the stationary value, we need to find the stationary points. Okay. Stationary points, that means you must find the value of y. Point. So point adalah koordinat. Alright. So awak kena cari y lah. Then okay, then we get a point. Let's say point A. So A is X is C and Y is D. We call it stationary points. And to identify minimum and maximum point, we have two methods. Okay, either by first derivative test or second derivative test. Okay, so you must list the interval where a function increasing or decreasing. Okay. Okay, for first derivative test. Okay, first derivative test, we have relative maximum point. Okay, relative maximum point. Okay, maximum that means the highest point lah. Right, highest point on the curve. Okay, tengok kat sini. Okay, let's say we have point A. Sini adalah point A. Highest point is A. So A occur when tangent, okay, tangent that is gradient of tangent dy dx is equals to 0. Mana tangent ni? Straight line ni. Okay, so ini adalah garisan tangent where dy dx is equals 0, that is parallel to x axis. So we have the value of x is equals to c. Okay. Before interval x is equals to c, we have dy dx is greater than 0. That is positive value. So the value of y is increases. That means dia increase, menaik lah ni. Kalau buat ni satu garisan tangent kat sini pun dia akan menaik. Kat sini pun dia akan naik. Okay, so dia akan menaik. Right. So the value of y is increases until x is equals to c, that is the highest value of x. And then selepas value of x tu, that is c kan, c kat atas. So when x greater than c, dy dx is less than 0. That means negative value. So y is decreases. Okay, gradient akan decrease lah, menurun. Ni kat sini menurun, sini pun akan jadi menurun. Okay, so the changes from positive to negative, it occur maximum point at x is equals to c. So kat sini point A. So dapatlah maximum point. Okay, for minimum point. Minimum point, that is the lowest point on the curve. Okay, kat mana? Sini. Let's say point B. Sini B. B is minimum point when tangent on a curve, okay, is bukan atas curve, tangent tu, tangent dekat apa, dia touch, okay, touch the curve when dy dx is equals to 0, when x is equals to c. There is tangent to a curve is parallel to x-axis. Okay. When x less than c, okay, when x less than c, okay, c ni kat mana? C ni adalah value of x dekat point B ya. Okay, when x less than c, value of y is decreases. Ni tangent. Okay, dy dx less than 0, dy dx less than 0. So sampailah dekat point x equals to c. Dy dx less than 0. And then when x greater than c, okay, when x greater than c, so y is increases. Dia akan menaik ni. Kat sini tangent dia akan menaik, tangent dia akan menaik. Okay, so dy dx greater than 0. Okay, the changes from negative to positive, ni negative to positive, right? Negative to positive, it occur a minimum point at x is equals to c. Kat sini lah ni point B ni. Right? Itu adalah minimum point. Perubahan decrease to increase value of dy dx. Right? Boleh ya faham apa maksud maximum and minimum point. Okay. Look at example. Okay, example 3. Example 3. Find the extremum point for y is equals to x cubed minus 3x squared plus 6 by using first derivative test. Hence, state where the function is increasing or decreasing, if any. Okay, so first, actually example 3 same as example 2. Right, function yang sama je. Okay, so you differentiate dy dx is equals to 3x squared minus 6x. Okay, then when you equate to 0, 3x squared minus 6x is equals to 0, and then we have quadratic, so you must factorize. Okay, so we get two values of x. We call as stationary values. Alright. Okay. Then when x is equal to 0, to find stationary point. X is equals to 0. So y is equals to 6. Kita dah cari ya. When x is equals to 2, so y is equals to 2. So we have 0, 6 and 2, 2 as stationary points. Okay, dah ada stationary points. So we want to determine extremum points using first derivative test. So based on stationary values, okay, you form a table. Since we have two stationary values, that means we have 3 intervals. Okay, so x, here is x equals to 0, x is equals to 2. Okay, interval from negative infinity to 0, 0 to 2, 2 to infinity. Okay, and then we have test value test value any value in interval negative infinity to 0. Let's say we take -1. Okay, 0 to 1 take value 1 positive, 2 to infinity 3. Okay, then check dy dx. Okay, and then using calculator. Okay, calculator, insert function. Mari kita tekan sama-sama ya. Insert function dy dx. There is 3 alpha x squared. Okay, minus 6 alpha x. Okay, tekan sama-sama. Okay, then press calculate button. Calculate. Okay, insert value -1. So -1 equal, double equal. Okay, so we get positive. Okay, positive 9. Okay, so fill in the blank. Positive. Ni positive. Tulis kita. Okay, next insert value 1. Okay ni, calculate, press calculate button. 1 equal, double equal. So we get -3, right? Okay. Then next calculate, insert 3 equal. So we get positive. Fill in the blank. So here is negative, here is positive. Boleh? Okay, then positive, that means increasing. Increasing. Okay, negative, that means decreasing, positive, increasing. Lukis macam tu. Okay, so the changes from increasing to decreasing, this one, it occur maximum point kat situ. Nampak tak? Ni maximum kan kalau sambung gitu. Okay, so occur maximum point at x is equals to 0. Right. From decrease, and then to increasing. So it occur here minimum point at x is equals to 2. Nampak tak kalau sambung tu? Okay, so kita tulis point maximum point at x is equals to 0. Okay, that means point 0.6 is maximum point. And then for minimum point occur at x is equals to 2. So point is 2, 2. 2, 2 is minimum point. Right. Okay, and then hence state where the function is increasing or decreasing. Okay, function is increasing, f. Okay, f f is increasing in interval. Okay, kat mana? Ni, interval negative infinity to 0 and 2 to infinity. Negative infinity to 0 and 2 to infinity. Alright, and then f is decreasing in interval decreasing. So decreasing, this one here. Interval 0 to 2. Right? First kita identify for extremum point. Extremum point, that means maximum point and minimum point. Okay, satu. And then kita identify for increasing or decreasing interval. Based on first derivative test. Last week kita buat sampai stationary points. Stationary points kita identify which one is maximum or minimum point. Boleh faham setakat ni? Salin dulu.
Boleh, madam.
Okay. Next example B. Find and determine the type of stationary points of fx is equals to 4x plus 9 over x by using first derivative test. Hence, state where the function is increasing or decreasing. Okay. So, find f prime x. F prime x is equals to 4 minus 9 over x squared. When f prime x is equals to 0, so 4 minus 9 over x squared is equals to 0. 9 over x squared is equals to 4. So x squared is equals to 9 over 4. So x is equals to plus minus 3 over 2. Right? So we have two values of stationary values. Right. Okay, and then find stationary points. Wajib dah tu cari. Okay, when x is equals to 3 over 2. So f prime, fx. Awak kena ingat fx tu adalah y. Kita nak cari y. So f, ni bukan f prime. X is equals to 4 times 3 over 2 plus 9 over 3 over 2. So fx is equals to, substitute into calculator. Dapat apa? Maisara? Amira? Oh, Maisara?
12, madam.
Positif. When x is equals to negative 3 over 2, so fx is negative.
Aku tak tahulah mana. Negatif 12. Oh, macam tu
Okay, negative. Negative 12. Okay, so stationary points are 3 over 2, 12 and negative 3 over 2, negative 12. Right, so we have two stationary points. Okay, then we want to check which one is minimum or maximum point. Right. Boleh ya? Dah? Dah ya? Okay, you form a table. 1, 2, 3, 4. Oh, freehand je. Okay, x is equals to negative 3 over 2, x equals to 3 over 2. Okay, first interval, negative infinity to negative 3 over 2. Negative 3 over 2 to positive 3 over 2. And then 3 over 2 to infinity. Okay, test value. Okay, any value lah dalam interval tu. Awak nak ambil negative 100 pun boleh juga. Kita ambil yang senang-senang je lah, boleh calculate. Okay, negative 2 saya ambil. Okay, negative 3 over 2 to 3 over 2. So, ambil 1. 3 over 2 to infinity. Substitute x is equal to 2. Okay, then check dy dx. Okay, dy dx. You substitute. Okay, terms kita tadi f prime deh. Okay, f prime x. Okay, so insert a function into your calculator. F prime. F prime is 4 minus 9 over alpha x squared. Boleh? Insert a value, a function into your calculator. Press calculate. C-A-L-C. Calculate button. Okay. Press negative 2. Equal value untuk test value tu. Double equal, so we get 7 over 4. Positif. Saya nak simbol je, sign positif negatif. Okay, positif. Okay, next calculate lagi. Positive 1 equal. Dapat negatif. Alright, calculate. 2 pula. So we get positive. Fill in the blank. Okay, positive. Oops. Positif. Negatif. Positif. Alright. Biasanya dia akan alternate sign. Alright. Selang-seli. Okay, so positive. That means increases. Decrease and then increasing. Alright. Jadi, the changes from increase to decrease. Ni kat sini. Nampak tak? Ni. Di sini. So, occur a maximum point. Maximum point occur at x is equals to negative 3 over 2. Negative 3 over 2. Okay, and then from decreasing, okay, the changes from decreasing to increasing. It occur a minimum point. So kat sini adalah minimum point at x is equals to 3 over 2. So tulislah. Okay, negative 3 over 2. Negative 3 over 2. Negative 12 is maximum point. Okay, and then 3 over 2, positive 12 is minimum point. How about interval for increasing or decreasing? Okay, fx or y, okay, fx is increasing in interval negative infinity to negative 3 over 2 and 3 over 2 to infinity. Okay. Okay, fx is decreasing in interval Negative 3 over 2 to 3 over 2. Ni saya based on this one lah. Ni decrease. Alright, decrease. Okay, and then increasing, increasing kat sini. Ni increase, sini increase. Menaik kan? Okay. So itulah menjawab soalan. Dah siap. Right? Boleh faham ya? To identify relative extremum point. Okay? Extremum point, that means both maximum and minimum point. Boleh faham ya? By using first derivative test. Nanti nak jawab soalan untuk group discussion ni. Tak faham tak nak jawab ni. Okay. Dah?
Kita siap dah.
Dah. Okay, next. Second derivative test. Okay. Using second method. Okay, second derivative test for maximum point if d squared y dx squared less than 0. That means negative. Okay, negative value when x is equals to c, then CFC is a relative maximum point. Okay, lebih kecil maksimum. Okay, negatif masam. Dia jadi gitulah kan. Negatif jadi masam. So maximum point. Okay, for minimum point, if d squared y dx squared greater than 0, that is positive. Okay, when x is equals to c, then CFC is a relative minimum point. Positif senyum. Okay, positif senyum. Bila senyum, muncullah minimum point. Boleh ingat? Positif senyum. Masam negatif. Okay, hafal tu. Okay, look at example. Example 4. Example 4 actually same as example 2 and 3. Okay, so ingat untuk cari extremum point using second derivative, step yang sama sahaja. Alright. First you differentiate. Given y is equals to x cubed minus 3x squared plus 6. Okay, so you must differentiate. Differentiate dy dx. Okay, bila dapat dy dx, okay, you equate to 0, so we get two values of x, right? We get x is equals to 0 and x is equals to 2. Tak semestinya 2 lah, ada juga dapat satu nilai. X is equals to 2. Okay, then to find a stationary point, that means you must find the value of y. Right, find the value of y. So dapatlah stationary points. Okay, then to find to identify extremum point. Okay, kita guna second derivative test. Alright. Jadi dy dx is equals to apa tu? 3x squared minus 6x and then differentiate again to get second derivative. So we have 6x minus 6. Okay. Then you substitute x is equals to 0. When x is equals to 0, so d squared y dx squared is equals to substitute 6 times 0 minus 6. Congak. Negative 6. Okay, that means less than 0. Okay, so when second derivative less than 0, that means it occur maximum or minimum? negatif, masam kan? Betul? So occur a maximum point at x is equals to 0. Alright? Boleh tulis ni. So maximum point 0. Apa ni? When x equals to 0, so y is equals to 6, right? Ni adalah maximum point. Okay. Then when x is equals to 2, okay, so d squared y dx squared is equals to 6 times 0 minus 6 is equals to, 6 times 2. 12 minus 6, we get 6 positive. So, greater than 0. So, kalau greater than 0, that means positive. Positif senyum. Senyum, it occur a minimum point. Okay, minimum point at x is equals to 2. So, tulis. Minimum point, ni x is equals to 2. 2, 2. Okay, 2 is minimum point. Bukan 6 kita ambil yang asal daripada stationary point. When x equals to 2, so y berapa? Okay, so dapatlah maximum point and minimum point using second derivative test. Okay kelas, faham ke tak? Maria?
Ya, madam. Faham.
Faham ke tak? Okay dah. Next. B. Okay, B Find and determine the types of stationary points of fx is equals to 4x plus 9 over x by using second derivative test. Okay. F prime x. Okay, differentiate, we get 4 minus 9 over x squared. Differentiate lah ya. Kita belajar satu topik apa? Topik 2, topik 3 kan? Differentiation. Memang dah master dah rasanya. Okay, then nak cari sekejap. Kita cari point dulu. Find ini example. Sama example 3. Sama example 3. So bila f prime x is equals to 0. So awak akan dapat x is equals to, recall balik. X is equals to plus minus 3 over 2. 3 over 2. Plus minus Okay. Then when x is equals to 3 over 2, so we get y is equals to 12. Sini y is equals to negative 2. Dapat ya? Okay. Next, second derivative. F double prime x is equals to f double prime, differentiate 4, we get 0. Okay, x squared in denominator, buat ni atas. So, awak akan dapat 18 over x cube for f double prime. Okay, then substitute when x is equals to 3 over 2, so f double prime 3 over 2 is equals to 18 over 3 over 2 cube. So we get berapa? Calculator. Zuhairi kelas ni kau? Cepat. When x is equals to negative 3/2. Apa? Atas tu positif tau. Husna? Berapa?
16/3.
Ni atas ni positif kan? Bawah negatif. Okay. So nampak tak? F double prime 3/2, so we get 16/3. So 16/3 is positive, greater than 0. So bila positif, that means occur minimum point. Positif senyum, kan? Minimum. Less than 0, that means masam. Okay. Occur a maximum point. So tulislah. Thus, point x 3/2, 3/2 12. 3/2 12 is minimum point. Okay, and then point negative 3/2 negative 12. Sorry, negative 12 ni. Okay, is maximum point. Okay, so you can compare lah. Compare with first derivative test. Sama ke tak? Okay. Ni guna second derivative test to identify extremum point, whether minimum or at the maximum point. Okay, so habislah how to identify the extremum point using first derivative and second derivative test. Okay, dah siap ya? Okay, next. Now we have some exercises. Number 1, 2, 3. You can try on your own. Answer is provided. And test yourself. Okay, optimization problem. Okay, definition. Okay, what is optimization problems? That is the largest or smallest value of a function subject to some kind of constraint. The constraint will be some condition that can usually be described by some equation. Okay, biasanya kita guna equation for sphere, cylinder, cone, pyramid. Okay, we have for sphere volume. V is equals to 4/3 pi r cube. Surface area 4 pi r squared. Cylinder, volume, surface area. Cone, volume, surface area. Pyramid. Ni biasalah. Okay. Yang lagi biasa cube kita ada kan, rectangular. Tu yang biasa-biasa sangat. Okay, so formula ni diberi. Tapi kalau diberi tak pandai guna pun tak jadi juga kan. Okay, buatlah exercise banyak-banyak. InsyaAllah awak ingatlah tu. Matematik. Wajib kan buat hari-hari. Okay. To solve optimization problems, we have some steps, okay, to follow lah. Okay, first, identify the variable to be maximized or minimized. Oops. Okay, let variable y. Okay, y in terms of apa? Okay, and then you express y into a single variable function. Let's say y is equals to fx. Y in terms of x. Single variable. Okay. Dia kalau y is equals to 2x plus 2z. Tak boleh ni. Ni ada dua variable. Single y, inilah single y. Right, jadikan y sebagai subjek. Right, so maksudnya kena jadikan y in terms of x or y in terms of z. Satu variable. Okay, then next solve. Okay, solve for first derivative is equals to 0. Untuk dapatkan apa? Untuk dapatkan value of x tadilah, stationary value. Right, you equate to 0. Okay, then verify the types of solutions of f prime at 0 by using the first or second derivative test. Okay, nak check lah sama ada maksimum ataupun minimum. And then get the optimum value y is equals to fx if it is required. Okay, let's look at example. Example 1. An open top box is to be made by cutting small congruent squares. Okay, squares from the corners of 12 centimeter by 12 centimeter sheet of tin and bending up the sides. How large should the squares cut from the corners be to make the volume of box maximum? Okay. So sekarang ni kita ada sheet of tin. Okay. Square lah ni. Square. So 12 by 12 lah. Right. So sini pun dia akan jadi 12 juga. 12 centimeter. So dia nak cut for each corner ni. 1, 2, 3, 4. Tapi tak tahu berapa cm yang patut kita cut so that the volume of the box is maximum. Right? So apa yang awak perlu fikir, kita boleh form equation lah. Right? So equation apa? Dia cerita pasal volume. So boleh kita form satu equation volume. Alright. Itu yang awak kena fikir. Okay. So dia ginilah bila sheet of tin tu dia bending up. Dia potong lepas tu jadikan box kan. Gitu. Gitu. So sini adalah X. Yang ni pula dia akan jadi total 12. 12 minus dengan 2X. Satu corner tu X. Okay, satu corner lagi X. So 2X lah. Okay, sini pun sama. Sebab dia square kan. So 12 minus 2X. So volume is equals to X, okay, height times width minus 12 minus 2X times width dengan panjang lebar. Okay. Okay. Then you expand. You expand one by one. Right? So expand lah. 12 times 12. 144 times dengan X. Okay, 12 times 2X. Negative 24X times dengan X. Okay, negative 2X times 12. Negative 2X times negative 2X. Okay. So we have the expansion is 144X, okay, minus 48X squared plus 4X cubed. Right, this one is V volume. Okay, so since we have the equation V in terms of X, that means you can differentiate V with respect to X. Okay, so V dV dx is equals to 144 minus 96x plus 12x squared. Right, differentiate correctly. Okay, then you equate to 0, dv dx is equals to 0. So 144 minus 96x plus 12x squared is equals to 0. We get quadratic equation, right? Okay, you factorize, so you get 12 minus 8x plus x squared. Is it correct? 12x squared. Okay. And then you factorize. So we get, cepat calculator. Correct. We get two values of x. X is equals to 2 or x is equals to 6. Right. Okay. Then by second derivative test, okay, by second derivative test, that means you differentiate again. D squared v dx squared is equals to, from this one lah, we get negative 96 plus 24x. Okay. Then kita check ya, which one is maximum. Okay, which one is maximum? When x is equals to 6, when x is equals to 6, so d squared y dx squared is equals to negative 96 plus 24 times 6. So we get calculator. Calculator. Berapa dapat? Apa?
48.
Positive. When x equals to 6, we get 48. Ya, betul kan? Positif. Greater than 0. So, positif senyum. Senyum that means minimum. Kita bukan nak minimum kan? Okay. Then, when x is equals to 2, we get
Negatif 48.
Negatif 48. So we get negative masam. That means maximum. Alright. So soalan dia nak maksimum kan? Okay. So when x is equals to 2, so it occur a maximum lah. X maksimum kan ni? Okay, betul. Masam. Okay, maksimum ya. Jadi x is equals to 2 is minimize the volume. Okay, so soalan dia nak berapa square kan yang boleh kita cut. So, okay, that means x squared is equals to 2 squared, that is equals to 4 unit cm squared. Should the squares cuts from each corner. Boleh faham tak? So maksudnya setiap corner tu kita potong 2 kali 2 lah. Okay. So satu square tu adalah 4 cm square. So ada 4 corner kan. 4 cm square. Satu 2, yang kedua, yang ketiga, yang keempat. So 4 corner tu lah kita patut potong. Setiap satu tu adalah 4 cm, 4 cm squared. Boleh faham tak? Kena faham ni sebab nanti nak jawab soalan group assignment tak dapat, rugi markah. Boleh ya? Awak imagine daripada sheet tin tu dia potong, lepas tu dia jadikan box. Right? Lepas tu nak maksimumkan volume. Okay. Sekejap. Oh, ni bukan minimize ni. Baru perasan. Sorry. Ni. Ni bukan minimize. Kita nak maximize. Alahai. Saya juga yang perasan. Maximize. Bukan minimize Kita nak maksimum. Okay. Next, example 2. A manufacturer needs to make a cylindrical can that will hold 1.5 liters of liquid. Determine the dimension of the can that will minimize the amount of material used in its construction. Okay. 1.5 liters of liquid. Jadi dia cerita pasal apa tu? Volume. Right. Itu adalah volume lah tu. Okay, so volume V is equals to 1.5 liters. Right. Cylinder, cylindrical can. Okay, so formula apa? Volume untuk cylinder pi, refer formula. Pi r squared H is equals to 1.5. You write H in terms of R, so we have 1.5 over pi r squared. Right? Okay. Awak dapat H in terms of R. And then, untuk silinder kita ada satu lagi formula, surface area. Right, surface area. So A is equals to, refer formula, 2 pi r squared plus 2 pi r H. Okay, so we have equation A in terms of R and H. So you cannot differentiate with two variables. Alright. Jadi kita kena jadikan dia dalam satu variable sahaja. Okay, that means we can write A in terms of R. So barulah boleh differentiate. Sebab ada H mana boleh. Okay, so now macam mana nak buat? You substitute, H ni into this one, H. So awak jadikan satu variable lah. Plus 2 pi r 1.5 over pi r squared. Simplify, cancel out pi r. So we have 2 pi r squared plus 3 over r. This one is equation of A. Dapatlah A in terms of R. Barulah boleh differentiate A with respect to R. So dA dR is equals to power buat depan. So we get 4 pi R. Okay. Differentiate 3 over R. So we get negative 3 over R squared. Okay. Then you equate dA dR is equals to 0. So we get 4 pi R minus 3 over R squared is equals to 0. Okay. To find the value of R lah. Okay, so 3 over r squared is equals to 4 pi r. Okay. And then r cube is equals to 3 over 4 pi. So r is cube roots of 3 over 4 pi. Ini adalah value of r. Dapat r baru. Okay, then salin dulu.
Madam,
Ya.
R squared ke R plus 3?
3. Oh, sini. Kejap. 3 over r squared. Betul. Ni adalah differentiate A with respect to R. So we get 4 pi R minus 3 over R squared. You equate to 0, kan? Lepas tu, bawa R ni R squared ni, darab dengan R ni. So dia akan jadi power 3 lah. Kan? So R cube is equals to 3 over 4 pi. So R is cube roots of 3 over 4 pi. Okay, Anis?
Okay, madam.
Okay. Then baru dapat R kan? Okay, then kita nak buat second derivative lah. Tadi first derivative. Okay, saya copy dulu. dA dr is equals to 4 pi r minus 3 over r squared. Okay. Then we want to find second derivative. D squared A dr squared is equals to 4 pi. Okay. R squared bawa naik atas. Okay. So akan dapat positif lah. Negative 2 times negative 3. So we get positive 6 over r cube. Right. For second derivative. Okay. Then with value of r is equals to cube roots of 3 over 4 pi. Kita nak check second derivative. Okay, d squared a dr squared is equals to 4 pi plus 6 over berapa tu? 3 over 4 pi. Ni ada cube roots. Right. This one is cube roots. Bracket power 3. Alright. So dia akan jadi cube roots dengan power 3 tu dah cancel out. So berapa? 6 24 over 3. 24 over 3 is 8. So 8 plus 4. 8 plus 4 is equals to 12. Is it correct? Let's check. 4 pi plus 8 so equals to 12. So 12 pi, that means greater than 0. Okay, positif. Positif senyum. Bila senyum, minimum. Okay. And then, cuba baca balik soalan tu. Determine the dimensions of the can that will minimize. Okay, minimize. Maksudnya nak minimum lah kan. So maksudnya betul lah value of R dia tu adalah cube roots of 3 over 4 pi. Bila minimize. Kan? Jadi, bila dah ada value of R, maksud dimension kat sini. Dimension, dia nak R tu berapa, dia nak H tu berapa. Variable kita ada dua kan, R dengan H. So R dah dapat tadi. So kita nak cari H lah pula. Okay, nak cari H macam mana? Gunalah value of R juga. That means when R is equals to cube roots of 3 over 4 pi, So H is equals to 1.5 over pi R cube roots of 3 over 4 pi. Pi R squared. Nah ni pi R squared. Itu ya. Daripada equation H. Okay. So tekan calculator. Dapatlah berapa? Cuba tekan. So H is equals to berapa Hazwani? Azam? Hafiz? Sekejap. Dalam point form. 1 point. Faham? Berapa hash? 1 point? Zairi?
1.24.
1.24. Unit? Unit apa? Oh tak ada. 1.24 unit. Okay, itulah value of H, height. Cuba tekan value untuk R tu. Cube roots of 3 over 4 pi dalam point form berapa? Zero point
62.
So tulislah balik. Thus the dimensions are R is equals to 0.62 unit and H is 1.24 unit. Dapatlah dimension dia. Janji awak dapatlah minimum tu dulu. Macam mana dapat minimum daripada second derivative greater than 0. Boleh faham? Kena berusaha juga faham. Okay? Okay, last one. Dah ke? Izzah dah? Izzah Fatini. Asdira. Hafiza. Dah siap?
Dah, Madam.
Okay, next. Example 3. A rectangle is bounded by the x-axis and the parabola y is equals to 25 minus x squared. This one is parabola. Okay. Shown. What length and width should the rectangle have so that its area is maximum? Area is maximum. Okay, dia bagi point dekat hujung sini. Ni adalah point dia adalah x, y. Xy that means distance from center, origin to this point is x. Alright, and then same as here is also x. Okay, then distance from hijau ni. Sini. Kat situ adalah y. Hijau tu Okay, so apa yang boleh kita nak buat ni dengan tahu jarak dia x tu dengan y tu, apa yang boleh kita buat adalah dia dua je sebenarnya kan. Area. Okay, kita boleh cari area of rectangular tu. Okay, that means this one lah, the shaded region. Okay, so area of the shaded region is A is equals to x plus x, so we get 2x times length times dengan width. Alright, so 2x, y. Okay, then awak kena ingatlah awak tak boleh differentiate with two variables. Okay, x and y. Okay, that means awak kena jadikan satu saja variable. Okay, differentiate A with respect to x or differentiate A with respect to y. Right, macam tu. Jadi sekarang ni dia bagi information yang ni. Okay, equation of parabola. Y is equals to 25 minus x squared. So you can substitute y into function A. So that we have 2x times 25 minus x squared. So you can expand, we get 50x minus 2x cubed. That is equation of A. Nampak tak? So dia dalam bentuk A in terms of X. So now we can differentiate A with respect to X. So we get 50 minus 6x squared. Okay, then when X is equals to, dA dx. When dA dx is equals to 0. So 50 minus 6x squared is equals to 0. Then equals to 50. So x is equals to, calculator. Square root of 50 over 6. Calculator, insert form. Correct? Betul Zuhairi? Siti
Betul,
Zuraida?
madam.
Betul. Jangan lupa ada plus minus sebab kuasa 2 kan? Okay, so x is equals to two values of x plus minus 5 set 3 over 3. Okay, sebelum ni example 1 and example 2 saya solve guna second derivative test. Okay, so yang ni kita try guna first derivative test. Sekejap. First derivative test. Dia bikin buat ni. Puzzle.
Tu dah buat dah.
Buat.
Tengok tu dah buat dah.
Okay, kejap. Dah ya? Kita form a table using first derivative test. Okay. X is equals to negative 5 set 3 over 3. Here is x equals to 5 set 3 over 3. Okay. Interval negative infinity to negative 5 set 3 over 3. Negative 5 set 3 over 3. Tulis interval. Okay, test value. Ambil lah berapa value dalam interval tu. Let's say saya ambil negative 10. Okay, then here is 0, positive 10. Okay dah. Okay, next test ni kat sini first dA dx. Okay, first derivative. Okay, then apa tadi? dA dx is 50 minus x squared. 6x squared. Okay, awak insert dalam calculator. Okay, first derivative 50 minus 6 alpha x squared. Okay. Okay, calculate. Press button calculate. Insert negative 10. equal. So we get negative, right? Okay, negative. Okay, calculate lagi. Insert 0 equal. So dapat positif. Okay, calculate. Insert lagi 10 equal. So we get negative. Make sure alternate sign dia selang-seli. Sini negatif, negatif, positif, negatif. Negative that means decrease. Positive increase. This one is decrease. Okay, so patah balik soalan. What length and width should the rectangle have so that its area is maximum? So kalau awak nampak maksimum tu berlaku kat mana? Choose seorang tolong jawab. Maksimum tu berlaku kat mana? Aida Hidayah. Based on table. Cepat. Ada ke tak ni? Amira, Hafizah, Nurul Nabila, Husna. Zuhairi. Cuba jawab sekali. Jana.
Berlaku dekat X equals to 5 set 3 over 3.
Nampak kan? Ni kat sini ni increase to decrease ni kat sini macam dengan masam situ so kat situlah berlaku maksimum. Okay, maksimum. Jadi kat mana? Dekat X is equals to 5 set 3 over 6 over 3. So maksimum kopi. Maximum occur at X is equals to 5 set 3 over 3. Okay, then soalan dia nak cari what length and width. Right. So length is 2x. So 2x is equals to 2 times 5 set 3 over 3. Tekan calculator. So 10 set 3 over 3 unit. Length. And then width is value of y. So y is equals to 25 minus x squared. 5 set 3 over 3 squared. Calculator. So we get 50 over 3 unit. Okay, dah siap. Boleh faham? Optimization problem. Habislah untuk 4.2. Nanti try lah tengok balik ya kalau ada yang tak faham tu. Untuk jawab soalan assignment, group assignment. Salin dulu. Dua enam tiga lapan enam. Okay, faham ya? Try masuk class point. Saya bagi link kat apa ni, grup WhatsApp. BKT6. Okay. Dah siap salin, try join class point. Saya bagi link dekat grup WhatsApp kelas. Baru seorang join tu. Hazwani, Maisara. Line kat rumah laju tak?
Laju madam.
Laju? Ya. Laju lah compare daripada college ni. Bahagia awak dia. Cepat. Tak. Mami ada kelas. Sekejap. Cepat masuk. Kod dia 26386. Baru 8 participants. Kalau masuk class point, maksudnya awak tak nampak ke Google Meet? Tak nampak tak? At least 15 participants join Yang lain-lain kenalah join juga. Kata laju kan. Okay. Tu ada exercise, bolehlah try. Okay, question number 1. Find the stationary point for y is equals to 2x minus 3 squared. Okay, awak try solve and then snap jawapan awak tu, solution, lepas tu hantar ya. Upload kat sini. Okay, start from now. Okay, cepat. Boleh upload.
Dah ke? Tadi kan mami dah siap. Siap. Siap.
Okay, cepat. Boleh upload jawapan. Ada 1 minit lagi. Sepuluh. Okay, dah habis ya. Masalah je. Okay, tahniah. Yang lain pun berusaha juga kan. Okay, kita tengok dulu. Next. Sekejap. Sekejap saya nak edit sikit. Number 2. Sekejap ya. Sekejap ya. Okay, next. Next question number 2. Lepas tu baru kita discuss. Find the extremum point for y is equals to 5 plus 4x minus x squared. A tu maximum to 9, B minimum negative to 9, C minimum to negative 9. Okay, start from now. Saya ada buat correction tu. Hazwani, laju. Amira, Hafiza, Suhairi. Okay, 3 minutes more. Okay, saya close submission. Majoriti dah hantar. Tengok leaderboard. Okay. Dah cukup lah ya untuk 2 soalan. Okay. Nah, mari kita tengok soalan. 2 soalan sahaja.